Hi everyone, this is Fahad Mirza and I welcome you to the channel. If you have ever built a prototype for a RAG pipeline where you need a vector store or an embedding store, you know that it is a bit of a pain to either install it from cloud or locally. For instance, if you're looking to install something like Postgres for as a vector store, you would need to install Postgres either locally or through some hosted service. You would have to enable or install some extensions, and even if you are going with some sort of hosted provider, you would have to sign up, you would have to provision a cluster, and then there are a lot of steps involved. And then there is also this issue of privacy, plus you would have to taken into account the throttling API and a lot of stuff. So in a nutshell, it is pain in the back to have a RAG vector store just for the prototyping. That is where I believe that the new option from Weaviate, which is embedding vector store or embedded Weaviate, is quite a good option. So in this video, not only we are going to install it locally, I will show you an end-to-end application with a RAG pipeline by using a local ModernBert embedding model, as how you can use this embedded Weaviate quite easily step by step. Plus we will install it all locally without signing up or spending a cent anywhere. Now, if you don't know what Weaviate is, I already have done heaps of videos on Weaviate. Weaviate is an open source vector database that stores both objects and vectors. So primarily it can be used as a quite efficient vector store. So what is vector store? If you want to do RAG, you need a vector store. And what is RAG? RAG stands for Retrieval Augmented Generation. RAG is used to provide context of your own data to large language models, because all of these LLMs, they have been trained on a huge amount of data, but they have no clue about your own data. If you want to provide the context of your own data to these LLMs, you need to use RAG. For that, what you do, you take your documents or data, you divide it into smaller pieces called as chunks. You convert those chunks into numerical representations or embeddings through an embedding model. For this, we are going to use ModernBert embed model from Nomic AI in this video, which we already have covered on the channel a lot. So once you have converted your data to embeddings, you need to store it somewhere, and that is where the vector store or embedding store comes into play. And for that, we are going to use this embedded Weaviate. And then whenever a user asks a query from an LLM for your about your data, you first do a similarity search of that query into vector store, return the similar results, append them to the user's prompt, give it to LLM, and then LLM, now having more context around your data, gives a more grounded response. So that is the whole thing, and this is what is called as RAG pipeline. Now what we are going to do, we are going to see how can we build this RAG pipeline by using this Weaviate embed all local, and by using this ModernBert embed model. And what I will be doing, I will be using this dataset from Hugging Face, which just includes some archive paper from the CS shorten. So let's go and try to get it installed. And let me also thank Massed Compute who are sponsoring the VM and GPU for this video. If you are looking to rent a GPU on very affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on range of GPUs, so do check them out. This is my Ubuntu system, and this is my GPU card, NVIDIA RTX 6000 with 48 GB of VRAM. Let's first create a virtual environment. Okay, next up, let's install all the prerequisites, which include torch, pandas, transformers, and then sentence transformer, dataset Weaviate client. And as we progress in the video, I will tell you why exactly we need these packages step by step. That will be easier to demonstrate. This is going to take a couple of minutes to install. Yeah, next up, let's launch Jupyter Notebook and we will play around with this Weaviate and stuff. Okay, so first up, let's grab some sample data. For that, as I showed you earlier, I'm using this data set from Hugging Face. So it is over 100,000 rows in it, as you can see. So let's wait for it to load it. That's done. And if you go to this data set on Hugging Face website, you will see that there are a lot of other columns like unnamed, something, title, abstract, and I'll just go down to scroll here. Where is the scroller? So there are other columns too which we don't want, like this and that. So for that, I just want title and abstract. So I'm just going to say that I'll just use this select column function, and I'll just create this data set so that I don't have to worry about other columns. Now, as I showed you here, it has over 100,000 rows. I don't want that many to just to show you the sample, because we just want to see the Weaviate embedded in action. So I'll just grab the top 100 rows from it. So I'm just shuffling it, and then I'm grabbing the top 100 rows after the shuffle data set, and then I'm just going to get the text and abstract in one row. That's it. Let me run it. Shouldn't take too long. That is already done, and it's all 100 rows are there now. Okay, so that is done. Next up, we need to grab our embedding model. As I told you earlier, I'm going to use this ModernBert embed model as an embedding model that converts our data set into numerical representation or embedding. I already have covered this model in great detail, where I have looked at it on various angles. So please check out my channel. Just search with ModernBert and you should be able to find it. Just to give you a quick idea, this ModernBert embed based model has been created by Nomic AI, is a fine-tuned version of ModernBert model, which is a modern BERT architecture. BERT models are simply encoder models. So what happens is that in the encoder models, there are bidirectional models. So they look at both previous and so they are forward looking and backward looking in simple words, and then they just output the numerical representation as their output. Mainly they are used for embedding, for RAG pipelines, for named entity recognition, for classification purposes or recommendation system. And that is where we are using this ModernBert embed model as an embedding model for our use case. So in this one, I'm just downloading it, and then this is the function I have defined to generate the embedding. So, and I'm using sentence transformer library, which is primarily geared towards the embedding models. So let me run it. And the model is downloaded. It's a very small model, just under 600 meg, and the mapping is also done, because this is what the mapping we are doing here, just to create a subset embedding, and that is already done as I was speaking. Okay, now in order to make this data Weaviate compatible, we need to convert it as a pandas data set, and it's a simple command to convert this embedding data set to the pandas data frame. So let me run it. Shouldn't take too long. That is there is. Now the beauty of it is data frame is that you see we grabbed this title, abstract, and text from the data set, and then we created the embeddings from it, and now we have stored embedding for each row in its own line, and we have put everything in a data frame, and now we can simply load it onto our Weaviate vector store. Now first up, we need to instantiate that embedded Weaviate, and this is the whole command which we need to use. So, but remember, this is for only prototyping, where we are spinning up this Weaviate instance directly from our code here, without having to use any other stuff. If you're looking for a production environment, then you would there are a lot of options with the Weaviate. And by the way, this video is not sponsored by Weaviate or anyone, so I'm just telling you, as is. So I believe Weaviate is available as a hosted service. I'm sure that is a paid option. There Weaviate Cloud as a self-managed instance. You can, and if you're hosting it as your own instance, you can host it locally, and then or with a cloud provider like AWS. Maybe you could use Kubernetes, because if especially if you want scalability and production deployment, you can use Kubernetes cluster. You can deploy it in hosted Kubernetes cluster like AWS EKS or Azure AKS or Google's GKE in GCP, which is Google Kubernetes Engine, and there are heaps of other options. You can even try out with Docker Compose, and then it is also available in Snowflake's Snowpark environment, and then Google Cloud Marketplace, AWS Marketplace, lot of other stuff which you can check on their website. Now I will be using Embedded Weaviate, which is an experimental client-based tool, and it's a deployment model that runs a Weaviate instance from your application code rather than from a standalone Weaviate server. Also, when embedded Weaviate starts for the first time, it creates a permanent data store in the location of your local system. And then when this client exits, the embedded Weaviate instance also exits, but the data persists. Okay, and so let me run it to instantiate this. And the instance is instantiated and it has produced a lot of metadata which you can ignore. Next up, let's specify some of the collections and properties. This is very specific to Weaviate. Within Weaviate, all individual data objects are based on a class property structure where a vector represents each data object. You can also connect data objects like in a traditional graph and search for data objects in the vector space. And then there are some modules, vector databases, collection, and that sort of stuff which you can check on their website. But collection is a unit where you put it in your data, and then collection has these properties. For example, here we have just specified a collection where we are going to store our data, and it creates a new collection, and then we are giving it the properties from our data set like text and title, and of course you will replace it with your own data if you are using a different data set. And the collection is created, and it also has again give us some metadata which you can ignore. And then this is where we are loading all of our data or embeddings into and embedding and metadata into our Weaviate collection. We are simply looping through and then appending it. And this is where we are doing the bulk upload with this insert underscore many function at the last line, as you can see here. So we already have created our instance of Weaviate locally, and then we have loaded the data. Now let's specify the query which we want to use in order to do the similarity search in that data. The query says that which paper applies ML to medical domain, and then we only want the top 3 results returned from that Weaviate vector store. And in order to, let me run it first, and then I'll show you how you can do the similarity search. And this is the final piece of puzzle in this reg setup where we are asking a query from Weaviate. We have given this query embedding with the query, and we want to convert it into tensor. Tensor is a multi-dimensional vector representation of your data. And then we are using the collection to find out the similar results from our vector store, and we are just limiting it to top 3 results, and then we are printing it out. So let me run it. And there you go. So as soon as I have run it, it has given me the top 3 results, and that is the whole magic of our RAG pipeline. You can simply pick these results. You can append it to user's prompt if it is what your application desires, and then LLM will have these 3 for example articles to append and to answer the user's query, appended with its own intelligence. So this is the whole idea behind RAG pipeline. But the main focus of this video was on this Weaviate's embedded vector store, which makes it so easy to do these prototypes, because normally when I'm doing videos I have to sometimes go with SQLite or some other stuff, or I have to just spin up a new Postgres instance and then go, or maybe get some cloud instance and then use it. But I think this could be a good option in order to for a dirty quick prototype. So that's it. I hope that you enjoyed it. Let me know what do you think about this, and please do watch these videos about ModernBert if you are interested in embedding models and RAG pipeline, because this model will be the new standard in 2025 for RAG pipelines for embedding models. That's it. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps. Thank you for watching.